Hello there, Narek is here, and today we're going to talk about the properties related to scalar product or dot product. The first property is when you have u scalar v, it can be written as v scalar u. The proof is very simple. U scalar v, it can be written as x prime plus y prime is the same thing as x prime x plus y prime y. So this is the first property. The second property is when you have u scalar, let's say v plus w, you can simply expand it like a normal equation. So it's u scalar v plus u scalar w. Alright, this is the second property. And the third property, which these are simple properties, let's say we have alpha u scalar beta v, and I want to calculate the scalar product. It's very simple. It's alpha times beta times u scalar v. Of course, alpha, it can be any real number. Similarly, beta can be any real number. So this is your third property. Now, there are some properties which are going to help us to find a new way to calculate a certain scalar product. We already talked about, in a previous video I already mentioned about three different methods in order to find out the scalar product between two vectors. But there are some formulas using these properties that are going to lead us in order to find out a new method, a new formula to calculate the scalar product. Let's first start by mentioning about the main properties. So whenever we have u plus v scalar u minus v, you simply have to expand it. So it's just like a plus b times a minus b. So it's u squared minus v squared, and that's it. You can use this property easily. The second case is when you have u plus v to the power of 2. So this will be u squared plus v squared plus 2 u scalar v. As you can see, we are having the scalar product u scalar v. From this part, I can deduce that u scalar v will be equal to 1 over 2 u plus v in norms to the power of 2 minus u in norms to the power of 2 minus v in norms again to the power of 2. Alright, so this is how you can find the scalar product, by using this formula. Similarly, when we have u minus v, so u minus v to the power of 2 is equal to u squared plus v squared minus 2u scalar v. From this I can also deduce again that u scalar v is equal to minus 1 over 2 the norm of u minus v to the power of 2 minus u squared minus v squared. So I can say that it's 1 over 2 u squared plus v squared minus u minus v to the power of 2. Alright, I'm going to take an example about this property. So let's say we have a certain triangle. This is my triangle, let's say. This is ABC. This is your vector U. This is your vector V. Automatically this will be U minus V. And I'm interested in calculating AB scalar AC. AB scalar AC, of course, it's the same thing as U scalar V. So you simply have to say that it's 1 over 2 AB squared plus AC squared minus U minus V is BC, so it's BC squared. Alright, so it's 1 over 2, and I will take some values in order to calculate. So it's AB, which is equal to 4, AC is equal to 3, and BC is equal to 6. So it's 1 over 2 times 16 plus 9 minus 36. I will have AB scalar AC is minus 11 over 2. As you can see, it's a negative value. What does it mean? It means that the angle is actually obtuse. That's why I'm having a negative value for the scalar product. Now let's go and talk about other properties related to the scalar product. Since we have U scalar V by definition, which is equal to U in norms times V in norms times cosine of the angle between U and V, I'm gonna call it cosine theta. So cosine theta is actually equal to U scalar V over the norm of U times the norm of V. U scalar V, it's x prime plus y prime over the square root of x squared plus y squared times the square root of x prime squared plus y prime squared. Alright, why not take an example about this case? Let's say we have A 2, 1, B minus 1, 0, and C 2, 2. Alright, and I'm interested in finding out AB scalar AC. First, I have to calculate the components of AB. AB vector is x of B minus x of A minus 1 minus 2 minus 3. 0 minus 1 is minus 1. Similarly, I will have to calculate the components of the vector AC. So it's x of C minus 2 minus 2, 0. And 2 minus 1, 1. So I'm interested in this case to calculate the cosine of the angle, not the scalar product. Of course, I will pass through the scalar product. So cosine of the angle theta is equal to x prime minus 3 times 0 plus 1 times minus 1 over the square root of x squared minus 3 to the power of 2 plus minus 1 to the power of 2 times the square root of 0 to the power of 2 plus 1 to the power of 2. So it's equal to 0 minus 1 over the square root of 9 plus 1 times 1 square root of 10. So cosine theta is equal to minus 1 over square root of 10. Alright, so this is how you calculate your cosine of a certain angle, of course, by deducing the scalar product and from the scalar product, the analytical form, and of course the norm of each vector. The last property related to the scalar product is when we have it's called the generalized form of Pythagoras theorem. So we have a certain triangle, let's say ABC. As you know, BC is equal to AC minus AB. All right, so BC squared will be equal to AC squared, AC minus AB to the power of 2. So it's AC squared plus AB squared minus 2 times AC scalar AB. So this is actually the generalized form of Pythagoras theorem. I'm going to remind you by talking about similarities with Pythagoras theorem. Let's say ABC was a right triangle at A. You would have written BC squared is equal to AC squared plus AB squared. So this is if A was equal to 90 degrees. Why? Because the scalar product will be 0. So whenever the scalar product, the angle is 90 degrees, the scalar product will be 0, you will have Pythagoras theorem. So this is the generalized form. Let's say you have random triangle and you are willing to find a certain side of this triangle, which is unknown. In this case it's BC. You can use this generalized form of Pythagoras theorem. BC squared is equal to AC squared plus AB squared minus 2 times AC scalar AB. Of course, you can replace AC scalar AB by AC times AB times cosine the angle between AB and AC and AB. So I'm going to take an example about this case also, and we're going to be able to finish the properties related to this scalar product. So let's say we have AB is equal to 4, AC is equal to 2, and the angle BAC is equal to 120 degrees. All right, so I will have to say that BC squared is equal to AC squared plus AB squared minus 2 times AC times AB times cosine of the angle, which is in this case 120. All right, so AC squared is actually 2 to the power of 2 plus AB squared is 4 to the power of 2 minus 2 times AC 2 times AB 4 times cosine of 120. So we will have 4 plus 16 minus 16 times cosine of 120. Cosine of 120 is actually equal to minus 1 over 2. So we will have 20 plus 8. So BC squared is actually equal to 28. And in case you want to calculate BC, is the square root of 28. And this is how you are able to find out your the side BC. All right. So this was the video related to the properties related to scalar product. I want to ask you to subscribe to my channel because I'll be uploading new material and you will be notified whenever I upload them. And I can also share with you my Instagram, Facebook account. You can contact me directly or you can simply leave a comment below. That's all for this time and see you later.